Here I'm going to be working with a simulation that allows us to look at what an electric field is. So the way this works is I have a slider up here which allows me to place down charges. Now all I want to look at right now is the electric field, so I'm going to get rid of all the rest of this. And let's see what a +1 charge looks like. Okay, this simulation uses a red dot to indicate a positive charge. When we get to negative charges, they'll be blue. And notice it just shows lines radiating outward. Okay, does this make sense? Remember, the electric field shows the force on a little positive charge due to the fixed charges. So anything I put here are the fixed charges, and now I can imagine bringing in a little positive charge, and it is going to move away from my set positive charge along one of these lines. If I set it here, it'll move straight out. If I set it here, it'll move straight out. If I set it on the line, it will follow the line outward. I can hit reset and look at the same thing with a -1 charge. It looks very similar to my +1 charge, except the dot is blue, believe it or not. What if I put in a bigger charge? So instead of -1, let's do -9. Now you can definitely see that it is blue, and we get more lines. This makes sense. If I bring in the same little positive charge, but I have a bigger charge in my fixed charges, then it's going to be more, in this case, attracted. So it'll be a stronger electric field. So in order to determine the size of a charge due to the electric field, I look at the number of field lines surrounding it. What if I have two charges of opposite signs? So here I have a -9, and let's just plunk down a +9. Notice the number of lines going into or out of each charge looks about the same. And if you imagine putting down a little positive charge between them, it'll be repelled by the plus and attracted to the minus, so you can see it just zooms straight across, showing that there is, an attraction between my two fixed charges, if you will. On the other hand, if I put down two same charges, there's this weird spot in the middle where things just kind of go squiggly, for lack of a better word. Imagine taking a little positive charge and placing it right smack dab between my two equal positive charges here. This one's going to say, I don't want you, and try to push it away, and this one's going to say, I don't want you, and try to push it away, and there will be a point in here in the middle where it's pushed equally by the two, in which case it's not going anywhere, and therefore there's no force, and you get this weird null in the electric field. If I take a positive charge and another positive charge that is a different magnitude, a smaller charge, I still get that weird null, but now it's shifted towards the positive, or the littler charge, because it's got to overcome the big charge, right? Whenever you see a null like this, you should think, those two charges have the same side, and therefore they're repelling each other. Now, we've looked at one charge. We've looked at a couple systems of two charges. Imagine having lots of charges. These maps get quite complicated and quite pretty all at the same time when you include lots of charges. So, for example, if you click Randomize, here we have a system of 4 charges. Look, here's the null between these two negatives. There's a null between those two positives, and each positive is connected via lines, though sometimes they're a little not so straight, if you will, to the charge of the opposite sign. Again, more complicated. I can tell this one and this one have the same sign because they're connected. This one and this one have opposite signs because there's a null in between. This one and this one are the same sign because they're connected. I can also tell that this charge is smaller than this one because it has fewer lines starting or stopping at it. And that this one and that one look like they would be fairly comparable, but I'd actually have to count the lines to determine if they actually are.